Hey guys, welcome to the world of parallel programming. So, in this session, we are going to get to know about how we can get information from our GPU during our program. So, if you recall the last time, we also get together with the hands-on to get with the system management interface and using the AMD SMI. We are trying to get the details with the what are the our system devices, what is the available memory. We also use the hipMemGetInfo to get the details like what is the grid size, thread dimensions, total memory size, and other details information like what is architecture and everything. And now here what we are going to do is this kind of information. It is not possible to do the hard coded. And we are writing our program. We need to know that into the handy. So inside a program, how we can actually fetch that information. So lucky for us in the hip programming, there are directives and there are methods which gets that job easier for us. So we can easily get all such details. So let's get a hands-on like some of the details which we can actually get. So we'll just go with a simple program. So where we'll try to fetch some of information like what is the name of the device that we will be working on, what is like a threads block, what are the L2 cache size, global memory size, what is a free memory, what is the architecture name, there is a details like what is a PCI bus ID. So all this information we can actually get. So it's just one of the few information that we can actually get. So for that, let's see what is the program. So if you see, the first of all, we need to define this device property structure. So there is a hip device property structure which is available. We can define that. And what we can do is we need to call this method, which is a hip get device properties. And we need to pass this pointer and the hip device that we want to use. Now, note that the system that we are using, it only uses the one devices. So the heap devices index is set to the 0. However, let's say when you are writing a heterogeneous kernel, you may have more than one device. Like you can have 8 GPUs, you can have a 16, 32, you can have a large cluster of like hundreds of systems. Now, in that event, it's not always that you will have a same property for every GPU or same available memory and same workload being executed. So in order to get those information dynamically, we need to use the device property. And with that, we can see we can do a lot of power and we can have a more granularity on what workload we are running at batch. So this is how we will begin. So first of all, we are trying to set hipSetDevice API. So we will be setting what is a hip device we are going to run. So basically on the GPU 0, what we have defined here, it will run everything. So even to get the property, to get the free memory info, to run the workload, everything, once we do this set device, it will run on that GPU only. So now when we call this hip device get property, it will get all the property into the pointer structure, which is a device property for hip device ID, which is 0. And we can also get the hipMemGetInfo to actually get at the real time what is the free memory available to us and the total memory available to us for the device that we have set. So now with that, see, this is how we can access. So device property is a structure which is having a lot of data. And one of the thing is like, see, we can get a major version of a system, minor version of a system. We can get a name of the system, ASIC revision we can get all the managed memory, pageable memory. And you see, this is just like a conversion from like a to megabytes for like a cache size. We can have global memory, we can have a shared memory per block, we can have a total constant memory as well. And if you see over here, we'll keep scrolling down, you can see that registrations per block, we have threads per block, we have a max thread dimensions, we have a grid size for X, Y, and Z. So 0, 1, and 2 will define the X, Y, and Z. And this is the total free memory. This is something that we have used the hipMemGetInfo. So this is the only thing which is called as a runtime, as and when we are going into the program, and anytime we can call. So it's not coming from the device property. It is not a static information. These are all the static information for the devices. And we can have a more details. What is architecture name? What is a compute node? Is it a multi GPU board? What is a PCI domain ID, bus ID, device ID, and many more data we can get. And this is only the few of them. For more details, we can always go and read into the specification of the hip device property, or we can just explore like a structure itself. Now, in order to run this, I have created one of the simple way. Like if I export this file name called as a hello GPU, which is this file name, and if I can just rerun this easily, like hipcc and this dollar file name .cpp, which is a file name extension for the source, and output name file name, which is a hip hello GPU.exe, and I'll run that executable file, and this will run for me. And as you can see, I'm getting a system major version, minor version, its device property, everything we are getting over here. So this is a way we can actually run into the real time, like what is available memory, what are the threads we can have while allocating the workload, what is our cache size we can utilize. And based on that, we can appropriately write our code, which would be more robust, which would be more flexible and scalable for using and harnessing the true power of the hardware capability that is available to us. So that's why it is one of the most important directives to follow and try and practice. So with that, thank you. Thank you for seeing this video. Please do share, like, and subscribe.